So now that we've walked through how to use a z or a t distribution, we've looked at an example with a z. Let's go through and look at an example with a t distribution. So it says the ankle brachial index ABI compares the blood pressure of a patient's arm to the blood pressure of the patient's leg. The ABI can be an indicator of different diseases, including arterial diseases. A healthy or normal ABI is 0.9 or greater. In a study, researchers obtained the ABI of 187 women with peripheral arterial disease. The results were a mean ABI of 0.64 with a standard deviation of 0.15. At the 5% significance level, do the data provide sufficient evidence to conclude that women with peripheral arterial disease have an unhealthy ABI? Okay, so usually what we say the first thing to do, right, is just write out the significance level. So alpha is going to be 0.05. Right, second thing then is just to write out all of the information that we're given. So we know sample size, right? Sample size is 187. The mean, right? So it's nothing about the population. So it's just the sample mean is 0.64 with a standard deviation. So it's still talking about the mean from the sample. So it's going to be S, 0.15. So if you're looking, right, S should be should be thinking a t-test. Okay. So the third thing, we're going to write the null and the alternative. And we're talking about a mean, so we have mu. It's saying it's greater than, right, 0.9 or greater. So if it's 0.9 or greater, right, that means it's equal to 0.9 or greater. So equal to 0.9 or greater. So that my alternative then should be less than 0.9. Right? So my alternative always includes that idea of equal to. So since it says 0.9 or greater, that's in my null, and my alternative will just be less than. So this is going to be a right-tailed test. And so the fourth thing is just to go through and find my my standardized test statistic, my t value. So if I recall what it looks like, x bar, right, minus mu naught over s divided by the square root of n. So in our case, we have 0.64 minus 0.9. We're going to put this in parentheses, divided by 0.15 divided by the square root of 187. All right, so let's throw this in our calculator with parentheses. 0.64 minus 0.9, close it, divided by parentheses 0.15, divided by the square root of 187. Move it out and close the parentheses. Ooh, very negative. Negative 23.7, right, 70. So that's very, very, very negative. So I can see, right, since it's so far away, right, I'm already thinking in my head we're going to reject the null, but we're still going to go through and find the p-value, draw my picture. So the fifth thing, right, draw, right, I'm going to draw my curve. Negative 23 is like way, way out here. And this little thing, negative 23.7, right, because 0 is right here. So I'm going to have TCDF. It's going to be the lower limit, right, which is negative 99,999. My upper limit, negative 23.7. And now my degrees of freedom. Now remember, degrees of freedom are n minus 1. So our sample size was 187. So my degrees of freedom would be 186. Okay, so this is going to be the p-value that I get, which is probably going to be 0, but we'll hit second vars. We're going to go down to TCDF, which is number 6 on my calculator. The lower limit, right, negative 99,999. My upper limit is negative 23.7. Degrees of freedom is 186. Paste that. Right, roughly 0, right? There may be some decimals, but it's just so small that the calculator is just saying it is basically 0. So 6 and 7, right, step 6 and 7 is we take our p-value, we compare it to alpha, right? Alpha is larger, so we are going to reject the null, Right? I'm just going to go down a little bit here and write my conclusion down here so I have a little bit of more room. And for this one, what I'm going to do is I am going to write it in the conclusion slightly different in two different ways. And they mean the same thing, but just so you can see that there's a little bit of a difference of how you can write them. But the first one is going to be, it says at the 5% level, or sorry, significance level. Significance level. The data provides sufficient evidence to conclude that the woman with PAD have a mean ABI less than 9, right? So that's one way. Or another way that you may see it, still starting out the same, at the 5% significance level, there is enough evidence to show that women with PAD have an unhealthy ABI. All right, so both are okay. They say slightly different verbiage, but still illustrate that same idea that there is enough evidence, right? It provides sufficient evidence to conclude sort of otherwise, right? That it's not 0.9 or greater. All right, so the last thing I want to say for this question is just going back up to steps 4 and 5. Like we saw with our z-test, we can actually do a t-test here and not have to plug everything into the formula. So we can sort of skip step 4 and really step 5. We can still draw our picture, but step 5 in terms of the t-CDF, we can do this on the calculator. So if we want the t-test, we go to our stat button. We go over to tests. We want the t-test and hit enter. We just have the statistics. So this would be 0.9, right? The mean we said was 0.64. The standard deviation, right, for sample, so we see S, 0.15. Sample size is 187. The alternative is less than, so we want the less than, and we're going to go ahead and calculate this. So you notice, right, the standardized test statistic is the same that we found. P-value, right, is 0, so we get all the results, but we don't have to plug it into the formula. So a lot of times it's a little bit faster to do it this route, but in case you just need the p-value and you're just given the standardized test statistic, you can still use that t-CDF.